Hello everyone. Today I am glad to share our work accepted by CVPR 2024, Learn to rectify the bias of clip for unsupervised semantic segmentation. Recently, large-scale vision language pre-trained model CLIP demonstrates superior zero-shot classification performance by comparing the degree of alignment between image feature and text features of different categories. However, good alignment between image-level visual feature and textual feature doesn't necessarily mean good alignment between pixel-level visual feature and textual feature. An expected bias, including space preference bias and class preference bias, inevitably appear when directly applying CLIP in unsupervised semantic segmentation, which may largely constrain the segmentation performance. From one aspect, CLIP exhibits space preference bias. CLIP performance apparently better for segmenting central objects than the ones distributed near the image boundary. It can be reflected by the fact that IOU decreases as the distance between the centers of object and the image increases. Areas in visualization within red boxes also show such space preference bias of CLIP and our rectification results. From the other aspect, there exists class preference bias between similar categories in CLIP. We show such trend between randomly selected classes by confusion matrix. Elements on diagonal line represent the right classification, while others are false. We observe a wide range of class preference bias introduced by CLIP. For example, according to the visualization, when ground truth is called, CLIP tends to incorrectly classify it as dog. This is the overall framework of our method, including a rectification stage and a distillation stage. We introduce a reference prompt to learn the class preference bias, and we project the positional embedding of vision transformer to model the space preference bias. Then the bias logic map can be obtained by adding reference logic map and positional logic map. We then subtract the bias logic map from query logic map to generate the rectified logics. Based on the rectified logics, we generate masks for different classes by Gumbel softmax operation. Then the contrastive loss is imposed between the masked visual feature and the text features of different categories to encourage the bias modeling and the rectification. It is worth noting that both encoders of CLIP are kept frozen. In order to enhance the segmentation performance, we distill the knowledge of rectified CLIP to the advanced segmentation architecture, DeepLab V2, which specially designed mask-guided, feature-guided, and test-guided loss terms. We compare with both non-language guided and CLIP-based unsupervised semantic segmentation methods to verify the superiority of our method and mainstream benchmarks. As shown in the left table, our model shows remarkably better results compared with the conventional non-language guided methods. In order to further evaluate the strength of features extracted from our distillation model, we also report our results of linear classification. Our method also performs favorably against previous CLIP-based methods, including CLIPy, MaskClip, Rico, and CLIP-S4 according to the right table. Extensive evaluations prove the effectiveness of each component in our method. With learnable reference and projection of positional embedding, we managed to model the bias brought by CLIP and rectify the bias with element-wise subtraction. Each proposed distillation loss item contributes to a better performance. Instead of directly using a regional classification head at the distillation stage, the student network, DeepLab V2, inherits and fixes the query and reference segmentation heads from our rectification stage, and utilizes logic subtraction to generate the final segmentation masks. Some visualization results are shown as follows. For more, please refer to our paper. Our poster will be presented on June 19 a.m. Thanks for listening.